Hi, Science 8. So let's go over the answers to the pressure worksheet. Um, so uh, let's go through the terms here. So pressure is defined as the amount of force that acts on a given area of an object. And compression is where the volume of something decreases as a result of the pressure. For example, a gas, because most of it, a gas is empty space, you can sort of pack the gas closer to each other, and so that decreases the volume. Um, when you have something that's sealed, so again, using gas as an example, and you heat it, what's going to happen is the particles inside are going to move around faster, and so they're going to be exerting more force against the interior walls of the container, and then that's going to build up pressure, which can ultimately lead to an explosion. Okay, so like if there's a canister of gas, that can happen. So here, force or pressure would be an appropriate answer. And so calculations we'll get into. The equation is force divided by area. Okay, and so remember, force we've looked at the last class. That's measured in newtons, and then area we can put that into meters squared. So the unit of pressure then would be newtons per meter squared, or we use this unit which is equivalent, which is called the Pascal, and that's given by the symbol PA. And just like having a kilometer, which is 1,000 meters, we have a kilopascal, which is 1,000 pascals. Okay, so let's get to the calculations here. So again, it's force divided by area. If we need to find the area and it's a rectangular object, we use length times width. Okay, so these ones here, 147 newtons divided by the area, 1 times 0.75, so that's 0.75 meters squared. So that gives you 196 pascals. Okay, so make sure when you answer this that you put the units here as well. Here you've got 700 divided by 4, right? 2 times 2, so 4 meters squared. That gives you 175 pascals. Now the other 3 and 4 are a little bit more complicated. The first thing you have to do is you have to change these units to meters. Okay, and it's because they're in centimeters, and so to change these into meters, you divide by 100. So 50 centimeters becomes 0.5 meters, 75 centimeters becomes 0.75 meters, and then you multiply those two to get the area, so we get 0.375 meters squared. Okay, and now we go 300 divided by that, and you get 800 pascals. Same thing here, divide these two by 100, so you get 0.5 and 0.5, multiply them to get the area, and then you get 2,400 pascals for that one. Okay, next section here is on fluids. So a fluid is a liquid, which most people recognize, but it's also a gas. Okay, so we define a fluid as something that's able to flow, and so gas is able to flow. Like you think about like hot air rising, that's an example of flow. Okay, so this is again gas and liquid. Okay, are both fluids. So now, in terms of that speed of flow, one of the terms that we use is called viscosity. Viscosity has to do with the reluctance of flow. So the more viscous something is, the slower it's going to flow. And so one of the properties that determines viscosity is how thick or thin the fluid is. So something like water, it would be considered thinner than something like molasses, which is basically like honey. So what we would say here is molasses is more viscous than water. And so some materials you want them to be viscous, and other materials you want them to be less viscous. So a thick fluid then, a more viscous fluid, is going to then flow slowly, slower than a thinner fluid. Okay, so you think about like pancake syrup. right? It flows slow because it's very viscous. And so the speed is defined as the flow rate. So that's how fast the fluid travels. Now this next part here is a little bit confusing. You get basically opposite results from heating depending on whether it's a liquid or a gas. So if we heat a liquid, that's going to decrease its viscosity, which means it's going to flow faster. And then the opposite would be true if we cool it, right? If we cool a liquid, then that would increase its viscosity. Now the gas behaves in the opposite fashion. If we heat a gas, it increases its viscosity. Again, that means it's going to flow slower. Now these three properties, let me explain what these mean. So certain things are able to stick together, stick to each other. So like water is able to stick to other water. So we call that cohesion. So if you think about something like a raindrop, in that raindrop that's traveling through the sky, you have water that's clinging to other water, and that's keeping that drop together. So that's what I mean by cohesion. Surface tension is basically what you get at the top of a body of say water, for example. So what this is, remember when we talked about forces, we described tension as a force that exists between something like a cable or a rope that's being pulled in opposite directions. So think of like something like a tug of war. As you're having the tug of war, the rope that's in between is gaining more tension. Now that is kind of what's happening at the surface of a body of water. So imagine water in a bowl. What's basically happening is you're getting a pulling effect on the surface that is coming from the edges of that container, and that added surface tension that now exists gives the top of the surface a little bit more strength, so that some items, some objects that would normally sink are able to basically stay afloat, and so they're floating because of that added surface tension. So if you think about something like a paperclip, if you put a paperclip on water carefully, so you don't put it you don't drop it in or don't put it on its edge, but you kind of do it carefully, you can actually get it to float. And so the density of the paperclip is greater than the water, so it will sink. But when it's floating at the top, that's due to the surface tension. And then finally, things that are able to cling to different materials, that's what we call adhesion. So, for example, water that's stuck to a leaf, like underneath the leaf, and is sort of defying gravity, that's because of what we call adhesion. And this is why we refer to things like tape and glues as adhesives, because they're able to stick to other materials. So here's a graph which basically showing you flow rate. I got some questions from students about this graph. It was a little bit on the complicated side. So the first one here, which substance is solid at room temperature? So like we just finished saying, gases and liquids are able to flow. So solids can't flow. So that means like if you have your stapler on your desk, it's not going to move, right? It's just going to sit there. And so when something's not moving, that means it would have a flow rate of 0, right? So like 0 centimeters per second. So right here, this is your 0 mark. And as you can see, this is staying at 0. So that substance C then at room temperature 20 degrees, which is right here, is a solid. Okay, so it's unable to flow. So that's what's indicative of a solid. When is viscosity of A and B equal? Right here where they intersect. Okay, and that's at 30 degrees Celsius. Okay, when the temperature is 20 degrees Celsius, which substance has the greatest flow rate? So here's 20 degrees Celsius. You go up the graph and you look at what's the highest, and so that would be material B. Okay, so that would have the greatest flow rate. Okay, at 50 degrees, we go up, and now it is substance A. Okay, and then this last one here, 5. So it's saying, so the graph only goes to 60 degrees Celsius, and it's saying, suppose at 65, which one, what would the flow rate of A be? So what you do is you basically, this is called extrapolation. You extend the graph, and you just basically keep it going. And so then if you look at where you are at 65, it's around, and this is an estimation, around about 32 or maybe 33 centimeters per second. Okay, and so that would be the flow rate. Okay, so again, hang on to all the everything that you're completing. We'll start the next topic. I'm going to have you go and look, use technology and work towards is, now that we kind of know what pressure is, I want you to look at how can we apply pressure in sort of a technical sense, like where can we use pressure in terms of real life applications. Okay, and so that's what the next worksheet will look at. Okay, so what I'd like you to do is complete the next worksheet, which will be on as an attachment, and have that done for Monday. And again, keep sending me the questions. I like that I'm getting questions from you. It shows that you're engaged in what you're doing, and you're trying to understand what we're covering. Okay, and again, if you don't have your textbook at home, use technology to get the answers, and don't worry if you can't get every answer. Okay, so just try to do your best. All right, again, stay safe, and I'll talk to you again on Monday. Okay, bye for now.